Hello everyone, welcome to Math Tutorial, where we unpack math concepts one video at a time. In this lesson, we're going to learn about equations and their solutions. We'll also take a look at how we can use mental math to check for solutions, but also build some strategies that'll help us check for solutions of more complex equations. Before we jump in, let's first recap some key background information. So we're going to be learning about algebra. And algebra is a branch of mathematics that uses variables. And variables are symbols or letters that represent unknown or undetermined numbers. Some examples of variables are a, b, c, x, y, z, and even a star, because technically anything from symbols to letters can be variables in algebra. Essentially, variables are like containers. They're able to hold various numeric values interchangeably with infinite possibilities. Which of the following can be used as a variable in algebra? M, T, X, 4, the division symbol, and a square. Make sure to choose all the answer choices that apply. Since variables can be represented by either letters or symbols, the correct answer choices are M, T, X, and the square. The 4 is an exact numeric amount, called a constant, because the value does not vary. And the division symbol represents one of the 4 basic operations in arithmetic, so it also cannot be used as a variable. When you start to use these variables in math expressions, you form what is called an algebraic expression. An algebraic expression is a mathematical phrase where variables and numeric values are combined using operational symbols like the addition, subtraction, multiplication, and division. Note, since we're starting to combine some numbers, letters, and operational symbols all together, you're going to notice that some symbols like the letter X and the multiplication sign look very similar, which actually can be kind of confusing. Give another example of a pair of letters, numbers, and operation symbols, like the X and the multiplication example, that would potentially be confused with one another. Amongst many possibilities of letters and symbols that can get confused with one another, some of them are the T with the plus, the O with the 0, and the L with the 1. But if you don't see your answer choice here, don't worry. There's definitely other possibilities. We'll just take a look at your answer and see what ideas you came up with. The good news is that because this was such a problem, mathematicians just made a habit of writing those letters slightly different so that they stand out from the rest, and that's what we do today. So let's return to that problem we had with the multiplication symbol and the letter X. To avoid the confusion between these two moving forward, especially in algebra, you'll start seeing that we're actually going to replace this use of the X for multiplication with some other new notation. The 3 that I'm going to show you today are very commonly used in algebra at all levels. The first one I'm going to show you is replacing the X with a dot. It is used in the same manner as you would use the X. It's just you're using a dot, nice and centered between the two variables or numbers, and vertically centered as well. The next one is actually going to be removing the multiplication symbol and putting the second either variable or number inside of parentheses, with no multiplication symbol between them. And the last one is actually removing the X altogether, having no operation symbol between them, and putting together the number with a variable. Now for the last one though, you have to be very careful because this only works when there's a variable involved. If there is no variables involved, then it will look like a bigger number. So if you had like a 5 times a 2, that would actually look like 52. So the third one only use if you're involving variables, whether it be 2 variables or a variable and a number. Great job with the background information. And now we're ready to cover new key concepts of this lesson. Building off of our knowledge about expressions, an equation is a mathematical sentence stating that 2 expressions are equal. Essentially, it still has all the same components as an expression, but now it has an equal sign as well. So you should still see variables, operation symbols, numbers, and an equal sign. If it doesn't have an equal sign, then it's just simply an expression. Which of the following are examples of algebraic expressions? And make sure to choose all the ones that apply. To recap, algebraic expressions are mathematical phrases where variables and numeric values are combined with the use of operational symbols only. Since the root of algebra is the use of variables, an algebraic expression, at the bare minimum, will have at least one variable, which is why 12 does not qualify as an algebraic expression. Instead, we call these constants because there is no variable attached to it that will make its value vary, thus it stays constantly at its value. And in 3x equals to 9, we have an equal sign, which qualifies this as an equation and not an algebraic expression. So these are the reasons why 3x equals to 9 and 12 were not the answers, But the rest, because they do have variables, they have numbers and operation symbols, and nothing else in extra, they all qualify as algebraic expressions. Which of the following are examples of equations? And again, make sure to select all the ones that apply. To recap, an equation is a mathematical sentence stating that two expressions are equal. So as long as we have an equal sign, then that is the makings of an equation. Since nowhere in the name or the definition of equation does it state the word algebraic, then that means that we don't really need a variable to still have an equation, which is why 15 equal to 10 plus 5 is still considered an equation even though it doesn't have a variable. The only ones that do not qualify as an equation are 8d minus 7 and b, because neither have an equal sign. So this last question leads us perfectly into the next section, which is that just because it has an equal sign, it does not mean that all equations are true as they're written. Instead, equations are like a balanced scale. When both sides are at an equal height, their weights are also equal in value and amount. So as a result, as long as you have a balanced scale, you have a true equation. But that's still not always the case when it comes to balanced scales. Sometimes they're out of balance, and that means their amounts were not equal. Let's take a look at a couple examples where we can see both of these cases in action. So the question is, how can we tell when an equation is either true or false? That's what we're going to look at right now. In our first example, we're going to see if the equation 4 plus 3 equal to 7 is true or false. And to do this, we have to see if adding 4 plus 3 gives us the same value as a 7, which is on the other side of the equal sign. In doing so, we now have the statement 7 equals to 7, which shows us that we have a balanced equation. And when we have a balanced equation, it shows that our statement is true, and our equation then is true. Okay, let's try another problem. Now we have 10 is equal to 8 plus 4. And we want to check if this is a true or false statement. We are going to determine this similarly to how we did the last question, with the first step being to determine what is the operation that needs to be performed. Then we will perform that operation and compare both sides of the equal sign to see if we have a balance. So let's add the 8 and the 4, which gives us 12, and compare that to the 10, which is on the other side of the equal sign. And putting both of these on the balance scale, we see that 12 is a greater amount than 10, and thus is not balanced on the balance scale. So the equation is not true or false. Which of the following equations are true statements? Make sure to choose all the ones that apply. After performing the operations of all the problems and then comparing the answers on both sides of the equal sign, only 3 out of the 6 answer choices gave us true statements. If you need, pause the video now to compare your solutions with those on the screen. Here we have the equation x plus 4 equals to 10, and we're supposed to check if it's true or false. As we saw earlier in this video, sometimes we do have equations that contain variables. And you may be asking yourself, well, how do I check an equation if it's true or false if I don't even know what the value of that variable is? And that is a great question, which leads us to our final key concept of this video. Solutions. A solution in algebra is the value of the variable that makes the equation true. And there's 3 keywords that I want you to really notice out of this definition, which is value of the variable that makes the equation true. Okay, let's do an example together. Is x equal to 6 the solution to the following equation, x plus 4 equal to 10? To do this problem, we're going to extract key information from this problem, like the value, the variable that the values can replace, and then we're going to check to see if that value makes the equation true. To help better visualize this problem, let's bring back this idea that our variable x is like a container. We will then place a 6 into this container and evaluate the rest of the problem. So we do 6 plus 4, which gives us 10, which matches the other side, giving us a balance. And since we have a balance, we see that the value of the variable does make the equation true, thus confirming that x equals to 6 is the solution of the equation. Let's try another. Is m equal to 7 a solution to the equation 3m equals to 24? Let's again create a container for the variable, but this time, instead of using a container, let's use a more appropriate math symbol, parentheses, to hold our value. We will then bring down the rest of the equation and place the value of the variable, 7, into the parentheses. So as we learned earlier in this video, a number next to a variable, or numbers separated by parentheses, means multiplication. So we're going to multiply 3 and 7, which gives us 21. Since 21 isn't equal to 24, then we know that the value of the variable did not make the equation true. And if the value of the variable did not make the equation true, then this shows us that this is not a solution. So m equals to 7 is not the solution to 3m equals to 24. Okay, so the question remains, If m equals to 7 is not the solution to 3m equals to 24, then what is? Okay, let's work this out together. Now, I know this is a problem you could probably do with mental math, but it's good habit to start to build some strategies and work habits to show your work, because these equations will get more complex as we progress through algebra. Alright, so we're going to use the exact same format we used when we checked for m equals to 7. So we're going to start off with the parentheses and bring down the rest of the equation, the 3, the equals, and the 24. And then we're going to imagine what number can go inside the parentheses that when multiplied with 3 will give us 24. The number is 8. So then we check our work. 3 times 8, does that equal 24? And indeed it does. So 24 equal to 24 is a true statement, and so the solution to this equation is m equal to 8. Here's your final question. Is b equal to 15 the solution for b plus 6 equal to 21? To practice showing our work, you're going to help me fill in each step along the way. What would the next step of work look like in this problem? If you chose to replace a variable b with 15, then you are correct. Okay, what would the next step look like? If you wrote that 21 is equal to 21, and that is a true statement, you are correct. Great job showing all your work one step at a time. Based on our work, we just showed that b equals to 15 is indeed the solution to this equation. Way to go unpacking today's algebra concepts. I'll catch you in the next math tutorial video.